Hello students. Next step after discussing about the chi-square test and its steps, we will now discuss the calculation of expected frequency. Calculation of expected frequency. You can say it is a theoretical prediction. It is a theoretical prediction of given data. Now we will consider one 2 by 2 means 2 into 2 table to show how to calculate the expected frequency. Now you will find in this grid A and B total of the column and total of the row. Now how many rows and columns are there? Column 1 and column 2 and row 1 and row 2. Now if we will try to calculate this cell value, it will be known as frequency 1.1. It is frequency 1.1 and this will be frequency 1.2 and the total of this row will be N1. Similarly, for this cell, name of this cell will be 2, 1 and this will be 2, 2 and the total of this row will be N2. Now here the total of first column we will consider as N3 and the total of second column we will consider as N4 and this total of this row and this total of this column will denote as only capital N. Now here one important formula is given to calculate the expected frequency, that is RT means row total into CT means column total. Row total and column total divided by N. Understand? Row total of the first row and total of the first column and the grand total N. By following this, what will be the calculating formula will be for this cell? So if we want to calculate f frequency 1 1, we will write n1 into n3. Clear? Row, total of row n1 and total of the column n3. So n1 and n3 divided by n. Now whatever number will be here, this number will be written and you will calculate. Similarly, if we will calculate, if you want to calculate this cell, that is F22, then what will be our formula? For F22, our formula will be RT, means row total. Row total means N2, and column total, that is N4, divided by grand total, that is N. Clear? Later on, whenever we will calculate the practical problem, we will apply this formula and apply this concept to take out the expected frequency. Now the next point we will discuss about the degrees of freedom. Degrees of freedom is a very interesting point, very interesting, you can say one case I will explain, so that the degrees of freedom will be clear actually what it is. Suppose there is person 1, person 2, person 3, person 4, person 5 and person 6. There are 6 persons, and in front of them 6 chairs are kept. So chair 1, chair 2, chair 3, chair 4, chair 5 and chair 6. Now you think, if you were the person number 1 and you are free to choose any of these chairs, it means what will be your probability to choose out of these 6 chairs? You can choose either one, that is first chair, or second chair, third chair, fourth chair, fifth chair, sixth chair. You will open. So now suppose first person has chosen any chair. Let's say first person has chosen the third chair. Now second person's chance will come. Now second person, whether the second person will have chance to choose all the 6 chairs? No, because already one is occupied. So he can choose only out of 1, 2, 3, 4, 5. Out of 5 chairs, he can choose only 1 chair. Now second person, suppose he has chosen the 6th chair. So Two persons has occupied two chairs. Now it's turn to third person. Third person is getting only 4 options to choose the chair because already third and sixth chair is occupied. Now third person is chosen the first one. Now it is turned to fourth person. Fourth person having option to choose only 3 out of only 3 chairs. Fourth person have chosen fifth chair. Now fifth person only 2 options, either second chair or fourth chair. Fifth person has chosen the second chair. Now degrees of freedom. Whether sixth person is free to choose any chair? No. He has to opt for only this fourth chair. That is why in case of statistics or in case of mathematics, we will check or we will take the degrees of freedom. We will denote it as small v is n minus 1. N minus 1 means always whatever the population will be, whatever the number of data will be, the n minus 1 will be the degrees of freedom. They are free to choose any options, but not the last one. Now, for example, in the previous grid, what we have just now discussed, there are how many columns? 2 columns. And how many rows? 2 rows. It means in that case, what will be the degrees of freedom? In that case, the degrees of freedom will be, let us suppose the column 1 will be m. It means column 1 degrees of freedom will be m1 and column 2 is mn1. So m having 2 minus 1 and n having 2 minus 1. It means 1 into 1, the degrees of freedom for the grid what we have discussed is 1. Okay. After this session, we will calculate one practical questions. So you note down this question first. From the following data, find out whether there is any relationship between the gender, that is male or female, and choice of color or preference of color. From the following data, we will provide the data. Find out whether there is any relationship between the gender and the preference of color. Now the data is color, males, females and total. So there will be 1, 2, 3, 4 means males 1 column, females 1 column. So 2 columns. Now colors. First pink, then black, and then yellow, and then again total. So pink under males, pink under males there will be 10, and females there will be 40, and total will be 50. For the black males 70, females 30, and total will be 100. Now for yellow, males 30, females 20, and total will be 50. So this is the data provided as males and females, and their preference of color is pink. Males 10, females 40 out of 50. Then black 70 males, 30 females out of total 100, and yellow 30 males and 20 females out of total 50. Now column wise we will make a total. It is 110, it is 90, and grand total will be 200. This is the question. Along with this question, or with the help of this question, what is the first step? We will have to fix, we have to set up the hypothesis. Null hypothesis means HO. We have to set up the null hypothesis. So in this case, our null hypothesis will be there is no difference. Write down. There is no difference between the preference of color by the gender. There is no difference between preference of color and gender. And obviously the alternate hypothesis will be there is difference between the preference of color and gender. So in the first case we will assume the null hypothesis as there is no relationship, no difference between the preference of color and gender, and our alternate hypothesis will be there is difference or there is some relationship between the preference of color and gender. So next we will come to its solution. So after getting that question, first of all we will have to take out the expected frequency from the given table. See the table we have prepared in the grid wise. We have explained there 2 into 2 grid. Here the grid is 3 into 2. See the three colors, pink, black and yellow, and column, male and female. So expected frequency we have calculated as per the formula. Expected frequency of row 1 and column 1. It means row total into column total divided by n. It is row total 50, column total that is 110 and grand total is 200. After calculating it is coming 27.5. That calculation you will also do in pen and paper in the RAF. Now expected frequency of 1 and 2, that is row total 100 and column total 110 and grand total 200. It's coming 55. So in the second cell we will write 55 and so on. Next we will write 27.5 and similarly we will calculate for this second that is for female expected frequency by applying this formula row total into column total divided by n. You will get 22.5, 45 and 22.5. This calculation you must do in your RAF and verify whether you are getting this all answers correctly or not. Now come to the calculation part. Calculating the chi-square as per the formula. We will have to arrange the observed value, expected value, the frequency. Now in the formula we are required O minus E, that is observed value minus expected value. So observed value minus expected value, then square it. So observed value minus expected value, its square, and then formula is summation. First of all, formula is O minus E whole square by E, that is expected value. This sum sigma. So what happened? In the question you will get 10 male, 70 male, 30 male, again 40 female, 30 female and 20 female. Now in the same grid where you have calculated the expected value, the expected value is given male 27.5, then 55, then 27.5, again for the female 22.5, 45 and 22.5. Now O minus E, that is 10 minus 27.5, it's coming minus 17.5. You will also calculate, you verify the answer. 70 minus 55 plus 15, like this we have got the values, that is O minus E. Now squaring the value, we have got this 306.25, 225, 6.25, again 306.25, 225 and 6.25. Now O minus E whole square divided by E. E means this. It means how we have got this value? 306.25 divided by 27.5. After calculation we will get 11.14 and similarly we will get 4.09, 0.23, 13.61, 5.00 and 0.28, and summation of this column is 34.35. Now this is the value, that is, we can say calculated value of chi-square. That is calculated value of chi-square. Next, we have to calculate the degrees of freedom. In the grid, how many rows are there? Total 3. That is one for pink, one for black, and one for yellow. 1, 2, 3. 3 columns are there. It means the degrees of freedom will be row -1 and column -1. Means how many rows are there? 3. So 3 minus 1 and column. How many columns are there? 2 minus 1. So ultimately we will get 3 minus 1 2 and 2 minus 1 1. Means the degrees of freedom for this particular case will be 2. Now you will have to refer that chi-square table, that is value table. Which table you have already downloaded from that given link. Okay. Now when you will open the table and check, there you will get the degrees of freedom from the beginning 1, 2, 3, 4, 5, 6. There you will check the degrees of freedom 2 and the column you will get 5%. That is level of significance. Either it is written 5% or it will be 0.05. Okay, so that is degrees of level of significance. So you will match the row and match the column. The tabulated value you will get, that is tabulated value you will get from the table 5.99. After calculating the statistical value and checking the chi-square table, the table value is given 5.99. You will verify it. Now the interesting part starts. As we have discussed earlier, the last step, that is step number 5 or step number 6, that is the last step. Yes, that is step number 5. If the calculated value, clear, if the calculated value is less than the table value, then null hypothesis will be accepted. But in this case, what happens? Table value is, calculated value. It is not table value, it is calculated value. Calculated value is more than the table value. It means what it will be? Null hypothesis accepted? No. Null hypothesis will be rejected. So automatically alternate hypothesis will be accepted. Now if this case, this calculated value will be less than 5.99, means it comes under the level of significance, then we will accept the null hypothesis and reject the alternate hypothesis. So I think if you will go through or follow from the very beginning, from the question and all the steps, ultimately up to here, your observation, and now what will be your statement? Your statement will be, for this case, there is difference or there is no relationship between the preference of color and the gender. Our null hypothesis was there is no difference, or there is there is no relationship between preference of color and the gender, and alternate hypothesis was there is difference or there is a relationship between the gender and preference of the color. As for our calculation, we can state our statement as there is difference or there is some relationship between the choice of color, preference of color, and the gender. Thank you. In the next session, we will give another question and we will solve it to clarify the whole chi-square test. Thank you.